Hey y'all, today we will be discussing how protein pumps work using ATP. We start off with the cell membrane, the phospholipid bilayer surrounding the protein pump, and the positive sodium ions and the positive potassium ions all around the cell. In this scenario, we are using sodium ions which are drawn blue and potassium ions which are drawn pink. However, other substances could also be moved through the P-class ion pumps in primary active transport, typically other metal ions such as magnesium and calcium. Resting state, the protein pump is closed on one side and open on the other. The closed side faces outwards and the open side faces into the cell. The protein pump has an affinity for the sodium ions when in its resting state, as they have to leave the cell, so the sodium ions bind themselves to the inside of the pump. Then, once the Na plus ions are in the pump, adenosine triphosphate, or ATP, attaches itself to the protein pump. The pump must be phosphorylated to be activated. Through this process, the ATP binds to the pump and converts into ADP because one bond is broken within the ATP to provide energy to facilitate the conformational change of the pump. One phosphorus ion remains bound to the pump. This causes the pump to close on the side with less concentration and open on the other side, allowing the sodium to be released out of the cell. Once the sodium ions are released, the potassium ions are attracted to the pump from outside the cell, as the pump now has an affinity towards the K plus ions due to the conformational change. Once the potassium ions are bound to the pump, the phosphorus ion unbinds from the protein pump, returning it back to its resting state, allowing the potassium ions to enter the cell. Now, why does this happen? Well, basically, this happens because cells need to maintain a proper electrical charge, which is essential for proper fluid and electrolyte balance in the body. The normal concentration of potassium within cells is especially important for the nervous system and is needed for normal nerve transmission. Period.